Okay, so the rest of this section is going to be working with, two functions at a time, or three functions at a time, and plugging things in, okay? The composition of a function is written in this form. So do you see how it says h of x equals g, and then it has this f, and then this x like this, yes? Okay, the way we read this is, function of g of f of x. Function of g of f of x. Okay? Meaning, anywhere there is an x in whatever function g stands for, I plug the function of f into that and then I can solve it. Okay? We are not going to talk about domains on this, so any of your homework that talks about tell me the domain of the composition, skip that part. Okay? Because it gets a little complicated and we don't need to go into that detail. Okay? So, we have two functions here. 2x, okay, f of x is 2x minus 7, okay? And then g of x is x squared plus 4. Equals x squared plus 4. And it wants to know what g of f of 3 is. Okay, g of f of 3. So here's what that means. It means first, I need to plug this green equation in to anywhere there is an x in the blue equation. Okay, so when I go to write g of f of x first, okay, that means I'm taking this equation, x squared plus 4, and I am plugging this equation in to its x. So it's going to say 2x minus 7 squared plus 4. Does that make sense? I'm literally plugging in, the whole equation to anywhere there is an x in the equation of g. Okay, because g was listed first. So, if I do this, how many of these do I have? 2. So I need to do what? If I have 2 of those, yeah, what's that called again? Foil.
Yeah.
So I need to FOIL. So I have 2x minus 7 times 2x minus 7, right? And then plus 4, because that's what was in my original equation. What's 2x times 2x? What is 2x times negative 7? Negative 14. And then I have another negative 14, yes? So negative 28x. And then what is negative 7 times negative 7? And then I have plus 4 on the outside still. Now, I simplify this. 4x squared minus 28x plus 53, yes? Okay, but in the original problem it said, what is the value of g of f of 3, yes? What do you think that means I need to do now? Yes, plug 3 into this equation now. So now I have 4 times, right, 3 squared minus 28 times 3 plus 53. What is 3 squared? And what's 9 times 4? So, okay, I'm gonna write this over here up a little bit. So I get 36. And what's 3 times negative 28? Negative what? 84? And then plus 53. So 36 and 53 together are 89, yes? And 89 minus 84 is 5. So now I have solved what g of f of 3 is. And the way they'll write this is they'll write it like this as your answer possibly. You can see it this way. when I plug 3 in to the composition function of g of f of x, I get 5 out. Okay? You have to show me work. There are lots of little places you can mess up here, so show me work. Okay, let's do some more compositions. Okay, so we now have this. We have f of x equals 4x to the negative 1. We have g of x equals 5x minus 2. Find the following. The first thing we want for A is f of g of x. Meaning what? What am I doing? Uh-huh. Yes. So I start with my f of x function, 4x to the negative 1. And I am taking this function and plugging it into the x spot. Okay? Plugging it into the x spot. So that you have 4, and then you have times 5x minus 2 to the negative 1. You're plugging the green equation in for the x of the black equation in order to have the f of g of x. Now, from there, I've got to simplify if I can. What is the one rule we know about exponents? Well, what is one rule we know about exponents? So what do I have to do? Put into fraction. Good. Okay. Now, the question is, what do I put into the fraction? Yes. So this transfers into 4 over 5x minus 2, because this whole thing has a negative 1 exponent. Can I do anything from there?
You can add a negative
Nope, that's as far as I can go. Okay? Can't factor anything out, I can't do anything else. That is what f of g of x is. Okay? Part B wants us to do g of f of x. So this time, what equation do I start with? G of f of x. What equation do I start with? The g. So I have f, or 5x minus 2, okay? Things just said right there. 5x minus 2. And then I'm going to plug in the black equation to anywhere there is an x in the green equation. Because I am plugging it in. I'm doing a function inside of a function. So you get this. 5, right? Times 4x to the negative 1 minus 2. Can I take that any further? Can I distribute? Yes, I can distribute. So if I distribute this, I get 20x to the negative 1 minus 2. Can I take that any further? I can't have a negative exponent, so what goes to the bottom?
20.
Is the negative 1 with the 20? It's only with the x, it's not in parentheses and on the outside of it, so it's only with the one thing that's next to it. Okay, so you get 20 over x minus 2. Does that make sense? Okay. Now the next one, this is something that maybe you didn't know you could do. We are going to do f of x. So I'm plugging f into itself. Okay? So if I start with the equation 4x to the negative 1, what am I plugging into this x spot? 4x to the negative one, but you still have that negative one. Okay, don't forget that. Now, let's talk about what we do there. What do you think our first step is to do? Distribute the, no, powers take precedence, yes? So distribute the power. So I have 4, and this negative 1 goes to that 4, yes? But it also goes to the x. What is a power to a power? You do what? No. Power to a power, you multiply. So what's negative 1 times negative 1? So I just get x. Okay? Now, what do we know about this 4 on the outside? It's multiplying to that, good. What else do you know about that 4 on the outside? It has a 1 as its power, right? Okay, and what happens when we multiply stuff with the same bases? You add their power, so what's 1 plus negative 1?
0.
Okay, so I have 4 plus negative 1, and I have this. So I get 4 to the 0, x. What is 4 to the 0? 1, and you get a solution, or a simplified answer of x. This is why I said you might want to use color. Okay, you have a $10 gift certificate to a paint store. The store is offering 15% off your entire purchase of any paints and painting supplies. You decide to purchase a $30 can of paint and a $25 worth of painting supplies. Use composition of functions to do the following. Find the sale price of your purchase when the $10 gift certificate is applied before the 15% discount, and find the sale price of your purchase when the 15% discount is applied before the $10 gift card. So we have to create equations to do that, yes? What's the first equation we would want to do? What do you think? So it wants us to find the sale price of the purchase when the $10 gift card is applied before. Meaning, what are you doing?
You're taking 15%.
Uh-huh.
Not for that one, you're actually.
Okay, on the first one, what are you doing first?
Figuring out how much you're spending.
Okay, yeah, but what is the first part of the first question? It says, find the sale price of your purchase when the $10 gift card is applied before the $15 discount, or 15% discount. So what are you doing first? Taking 10 away, right? So my first equation should say my total, whatever my total is, which we don't know, correct? Minus 10. That's my first function. Because the first part is, what happens if I just take $10 away first? Okay, the second equation says, what are you doing first?
Taking 15%.
Taking 15%. How do you represent 15%?
So 1/15?
It will, guys, 15%, would be, well, we would wanna subtract, would be 0.15x, yes? Because 15% of the total, but what's x minus 0.15x? What's 1 minus 0.15? You get 0.85. So my second equation can just be 0.85 x. I have two equations now. This represents what it cost with just $10 taken away. This represents what it costs with 15% taken away first.
How did you add?
You mean how did I subtract them?
Oh, yeah.
Because I had x minus 0.15x, which means I have 1 minus 0.15.
Oh,
So I get two equations like that. Now, it wants to know different compositions of it, yes? It wants to know, the first one wants to know, the gift card first, yes? It wants to know this, f of g of x. And the other one wants to know g of f of x. Does that make sense? So it wants gift card first, then the percent, and this one wants percent first, then the gift card, yes? Oh, yeah. Okay, so now I'm going to plug things in. X minus 10, which means I'm plugging 0.85 x minus 10 in now for that equation, correct? Okay, 0.85 x minus 10. The second one, I would get the equation of, I would have 0.85 x, so I'm plugging this equation in there. So you get 0.85 times x minus 10. Okay. So then we can solve from there, okay? Because we have some equations and we can solve if they tell us, did they tell us how much we spend? Yes, they told us how much we spent. How much did we spend?
30,
Plus,
25,
which is
50.
55. So now I can plug 55 into x and solve from here. So if I say 0.85 times 55, right? Minus 10, how much money do you spend this way? What's 0.85 times 55? Kaden, put your computer away.
55.85.
It's what?
I thought we were,
That's 0.85 times 55
I thought we were adding.
minus 10.
It's gonna be 36 plus.
$36.75. So if you take away the $10 gift card first and then the percent discount, you spend $36.75. Okay? Now, let's do it the other way. Let's plug it in here, 0.85 times, and it's 55. And then it's minus 10, right? And let's see how much we spend this way. What is 55 minus 10? Times 0.85,
38.25.
38.25. So which is the better deal? To take the gift card first and then the 15% discount, or to take the discount first and then the $10 gift card?
Wait,
No,
other way around.
other way around. Yes, the sale price $36.75 when the 15% discount is applied before the $10 saves you more money. Because we plugged a function within a function, okay, it saves us more money when we take a discount first and then subtract the $10, which makes sense, right? Because when you're taking 15% of your total bill, it's gonna be more money off that way than when you subtract $10 from it first and then take 15% off. Okay, Kohl's does a really good job with that. You can use their 15% coupon all the time and then use your Kohl's cash, or then use your gift card or whatever. And some restaurants or some places don't allow you to do the discount, the percentage first, they make you do the money off first. Because they're losing more money. Okay, so you're working on compositions today for homework.